bite light. Start, huh? Okay. So last class we are discussing the features of the Java language. We are discussing the different features of the Java language. See, right now till now what we have completed is we have completed the installation of Java, and we want to write Java programs. We want to write Java programs. If you really want to write good Java programs, you should know all this. This is the prime thing now. Okay. So the different so Java gives you these features of Java language now. Features of Java language. What are the different things it gives you? It gives you character set, then keywords, then identifiers, then variables, then data types, then literals, then operators, then you have got control statements. So these are the few things the Java language gives you for writing logics. So you have finished installation of Java, and right now we want to write logics. So if you really want to write logics, you should know all this very clearly. Some things are very easier, we can finish it off fast. Some things are big, so we have to put little effort and learn. So let's see now. See here, among these very important are, see, which I put star, this one, they are very, very important. Data types, operators, control statements. These are very important in a language. These three things are very, very important in a language. Okay. So because when you decide which language to choose for programming, most of the time we'll be looking into, first thing is data types only. First thing is data types. So these three things are important, but see, it doesn't mean that only these things are sufficient to write a program. You need the support of all these 8 things. So I'll start off with the first one. Okay, I think I completed the first one in the last class. Character set. Now I want to write a Java program. Yes or no? So how will you write your Java program? So you have to use something called as character set. And what are the different character set you got? Digits. Yes. So you got one is you got what? The different character sets you got are digits. I completed this one. Okay, then you got alphabets. Then you got special characters. So you're writing a Java program, you can use these 3 character set. There are 3 types of character set provided by Java. 3 types. Okay, these are the 3 types of characters. Digits means you can use between 0 to 9. Alphabets means capital A to Z or small a to Z. Special character means everything. Multiplication, plus, minus, so many, semicolon. These are all called as special character. All these characters you can use. So using all this, combination of all this only you write your Java program. Character set is clear now? So if at all you want to write a Java program, so we are starting from the basics now. We have completed installation of Java, and we are right now going from the very normal basics. Are you clear with the character set? Fine. Next is keywords. Yes or no? Are you clear with the character set? Do you have any questions? So if at all you want to write a Java program, your program should contain only these things, nothing apart from this. Understood? So it's almost all following C syntax now. In C also, how do you write a program now? Huh? In C, how do you write a program? Using these things only. Same. Okay. So are you clear with this? Shall I clear? So next comes what? Keywords. So in Java, how many keywords are there? Huh? So first one is over. Next one is keywords. Keywords in Java, there are 50 keywords in Java. How many? 50 keywords. And the list I mentioned in the last class. So first of all, what is keyword? Keywords are a set of words with some predefined meaning. Keywords are some set of characters with some predefined meaning. These are called as keywords. How many types of keywords are there? Yes, let's see now. I think it's visible. This is visible now. So how many types of keywords are there? Totally 50. Sit and count. 8 means they are primitive types, user defined types, access keywords, exception handling, statements. There are totally 50 keywords. Okay, there are totally 50 keywords. If you sit and count all of them, totally it will become 50. Okay, there are totally 50 keywords. Okay, but one more thing, last class which I forgot to tell you was, there is something called as literal values. There is something called as literal values. See, null, true, false. What are literals you'll be seeing next. Okay, but these are not keywords. These are actually called as values. These are not keywords. These are actually called as, sorry, these are not, see I have mentioned here, but not keywords. They are literal values but not keywords. So we'll be discussing about what are literal values later. Okay, but rest all what you are seeing are all keywords. Rest all whatever you are seeing are keywords. Are you clear? So including this it becomes 53. These 53 things you should not use as what? Names. You should not use as identifiers. Names means identifiers. Okay, so these are values but are not keywords. I'll be telling you what are literal values. So remember these three literal values: null, true, false. But they are not keywords. Fine. Next what we saw was what? Identifiers. What are identifiers? They are names. See, it's a name given to a what? It's a name given to a variable, method, class, interface or package. Don't worry what is interface, package and all right now, but it's a name what you give. It should contain only what? Alphabets, digits and only two special symbols. When you are giving a name now or identifier, only two special symbols can be used. What are they? Underscore and dollar, that's it. And first character should be an alphabet and it should not be what? Sorry, it can be a alphabet or underscore or dollar. Only these three things. The first character of your identifier should be any of these three, but not a digit. It cannot have a space. It cannot be a keyword. And I have given you examples for this. Are you clear with identifiers? So you are done with most of the things. So if you want to write a good Java program, all these things are very, very essential now. Otherwise you can't write. So see, when you start writing program now, you want basics. So if you want to learn basics, we are covering the basics now. Once you are clear with basics, you can write the length of the program can be anything now. And almost all the basics of Java is what? Related to C itself. There's hardly any difference you are finding. There's hardly any difference. The difference will come only here, you know where? Data types. Rest all are same. Understood? Rest all the things are same. Operators, this thing and all. So I'll be moving to data types now. Anyway, next. But we'll complete off variables. So what's a variable now? It's a name, memory, location that might be assigned a value. Yes or no? A value in a variable can be changed now. Are you clear with that? Int A. See the example for that. Class demo PSVM int A. You are declaring a variable. You will give the value A is equal to 5. SOP A, it prints what? 5. SOP A, it prints 5. Now I will say A is equal to 9. SOP A, what it prints? 9. It can be changed. So I will be explaining more in detail this. But the value in a variable can be changed. Marker, no? Okay. Marker. It's not writing properly. So A is equal to 9. So it can be changed. Done. So this is a variable. And you will be seeing more of this. You can have many variables. See, like this is the syntax. You will have a variable name. Understood? What data type? I will be covering data type now and value. This expression I will explain you in detail today. But just I told you what is a variable. Variable is a named memory location where you can store a value. I'll be going more deeper into that. Fine. So now we are entering data types, which we were discussing in the last class. Now we are entering data types, which we were discussing in the last class. Done now? So I'll move into data types now, which we were discussing in the last class. Till here you have any questions? No? I'll move into data types. So almost all these basics we are covering. See, it's almost all similar to C. There's hardly any difference between C and Java. So Java is very easy language. You don't have to worry. Okay, in Java we have to only learn what now? Oops. All the basics of C is similar to, or all the basics of Java is similar to C. Ditto to ditto it is same. And this is proof what I am showing to you. Only you have to learn oops here. You're very comfortable with the syntax of C. Okay. But let's see how rich is Java even in these basic things now. Okay, so now see we completed all this and I'll be moving into data types now. We are covering this. This itself will take some time. Okay, then we'll move to literals, operators, control statements. All are same. To write programs, these three are very important. To write programs, these three are very, very important. You cannot write a logic without what? Can you write a logic without data type, operator, control statements? You can't write. So to write logic, these three are very important. But doesn't mean only three are important. All of them are required. Among them, these three are important. Now, in these 8 things, 7 things are very much similar to C. One thing which is different from C is data types. One thing which is different from C is data types. So we are going to study this data types only in depth now. Okay. And in every language, we nearly spend lot of time in learning what? Data types. Every language this happens. The 7 things will cover up very fast. But in data types, we spend lot of time. Okay. Here also in Java, in C also you spend lot of time in data types. How much your time you spend? Nearly 4-5 months you spend to learn what? Data types. Okay, you start with primitives and then you enter what? User defined. User defined means what? Structure, enum and all that. So there you enter. And there you spend lot of time in learning your user defined data types. Okay, so that means you'll have arrays. So many things are there. Here also all that support is there. So here also minimum 2-3 months is basically required. Reason is you know C syntax. Because in C you don't know anything, that's why it will take around 4 to 5 months for you to learn what? Data types. So since you know something about C, in Java at least time taken for learning data types is 2 to 3 months. That's it. It will reduce. And in one learning time also reduces. Advantages in Java is they are more user friendly. The data types in Java are very, very user friendly and are very, 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 very powerful. Okay, as compared to C, the data types of Java are very powerful. So I told you so much information. I compared the C data types and Java data types little. Okay, I will compare it and more we are going on to compare, no doubt about it. But the first question is, what is a data type? Why it is used? This is the first question what we get. Yes or no? So what is a data type now? We'll compare, see the different, we compared, what is that we compared? The data type, difference between C data types and Java data types. What I told you, Java data types are easy to learn. Okay, easy to use. You'll only start understanding. When you start seeing, you'll only understand. C data types are complicated to learn, complicated to use. On top of that, Java data types, see, C data types and Java data types. If you want, I'll list it here. C data types and Java data types. Okay, not user friendly. Example, structure, enum. These are all user defined, no? They are very difficult to learn and use. Yes or no? Structure means what will happen? You'll run away. That's it. As soon as user defined data types comes, you'll run away and see. But here it is very easy. So user friendly data types. Primitives are there. Primitives same. But when it comes to user defined, lot of things will change. Not user friendly. Then simple, difficult to use. See, difficult to use. Can you use on user defined data type in C structure? To use it, what you have to know? Pointer. Learning pointer means what? Again you run away. So that difficult it is. But here, easy to use. Then next, less powerful. Means even though you put so much of effort and learn it, it is not that powerful. But here, very powerful. Your user defined data types are very powerful. Okay, like that, more differences are there. Here in C data types, we cannot implement oops. You don't know what is oops right now. We'll be seeing it. But in Java data types, you can implement oops. Like that, very powerful it is. Very, very powerful. Okay. So it will take a lot of time for you to understand this, but not as much as C. Even though I am saying it takes a lot of time, I am not saying it will take as much as C. It will take hardly 2 months, that's it. Clear? So all this we can finish off very fast. This only will be continuing throughout the course. At least 2 months I will be covering only data types. Literals are easy. Operators you will understand. You know what are operators now? Plus, minus, all things you know. Last one is control statements. If, else and all that. Clear? So I'll get back into data types. Are you clear with this? Okay, the first question is, why do you use a data type? What is a data type? Why do you use a data type? Last class I gave you some info about all this. Understood? No, data types are not used for declaring variables. You can say that's one of the reason. Data type is used for declaring a variable, agreed. Understood? But why are you declaring a variable and a data type? To store value. That's the prime reason data types have been given to you. Understood? A data type is primarily given for you for what? Storing values. Now what is so important about storing a value might be the next question. Why do you want to store a value? Okay. See, you cannot write a logic without values. Remember that. If at all you want to write a logic in any programming language, any language, see, all programming languages we do what? Write logic. So can you write a logic without value? Impossible. So to write logic we need value. And when you want to use the value you have to store it somewhere. It becomes so obvious. So that is the reason we need data types. Understood? So I'll start seeing this now. See, to be very precise to you, why a data type will be used is, look at this diagram, you'll get the idea. Then I'll continue with data types. You'll be having very rich UI. Till now I'm not showing you how to read from the keyboard and all that. Okay. Later on we'll see how to get dynamic values from into our application. Right now we are writing int a is equal to 10, int b is equal to 5. We have to get it from the keyboard now dynamically. We are hard coding the values. We'll get it. Okay. So that time you'll understand now. But here see, this is how it happened. Enter employee. You'll be having screens like this. You'll be having a screen. Enter employee ID. The screen will be there. Enter name. So like this you'll be having very colorful screens and you'll be having a submit button. Like this, not only one fields, two fields in there, multiple values will be there. And these values will enter into your application. See, this is a common scenario. This is user input screen. And this is your application. Remember that. You write any application in the world you write. Okay, same concept. You'll get the values, you'll process the values, and then you'll give back some output you'll give. Depending on what input he has given, you'll give back the output. Okay, only which language you use to develop your application, you decide. Are you going to develop the application using C, C++, COBOL, Java, Pascal, Fortran? You decide. And a language is greatly decided on what scenario? A easy language is decided on these 8 things first. Means which language to code to use will be decided on these 8 factors. Easiness. And at the same time it should be what? Powerful, user friendly, portable. So that's how languages are chosen. So I'll give you some assignment now. You can choose any language. But end of the day you will see that Java is only found to be the easiest language. Okay, writing any logic now becomes very easy in Java. Understood? Reasons you will only start understanding. There's hardly 4-5 classes. And you're already getting the comfort level of Java. More classes progresses, you will only get the idea. So see now, we want write logic. But to write logic I need this value. So I have to store it somewhere now. So what we do, generally see now, ID will be a numerical value. Understood? And this will be a string value. Depending on the type of value, we start using what? Data types. So if I get a value, generally this is the scenario. We'll have one data type. Int is one data type. The syntax will go like this. See, the syntax always goes like this. Data type, variable name, value. This is the syntax. So value will come dynamically to you. That you'll store it in a variable. But you are telling now very clearly that variable is of type what? Means this variable is going to store what type of value? Integer type of value. And it cannot store any other type of value. Understood? So we clearly tell, like during runtime, this variable should hold only this type of a value. So that's what we say. See, int employee ID is equal to, we get it dynamically, don't worry. I'll enter 101 here and I'll enter something like Ravi. So these values will come here now. It will be stored here. String name is equal to Ravi. The values will be stored here. So depending on the type of value, we choose the data type. Remember this. Right now, data types we are hard coding and learning. So first we learn it with hard coding. Why we learn it with hard coding? To learn it will be easy. And later on when you start getting dynamic values, that time you'll get the clear idea which data type to use where. There you should not have confusion. Because when you start developing applications now, there you should be very clear with, this is the value, I store that in which data type. It should be so perfect. You should not have any doubts there. Clear this? So this is the syntax, remember that? To store value, data type, we are learning data types. Variables are what? Named memory location. And finally you'll be getting a value. Understood? So right now what we are doing is, in our program, we are writing the code like this. Class demo, see this? Public static void main, I'll write int a is equal to 5. So this is value. A is what? Variable name. Means it's a named memory location. In that memory, I'm storing a value of 5. Okay, and it is of type int. So in A, I can store what? Only int value. As simple as this. See how easy it is to learn data types in Java. Following now? How easy it is to learn data types in Java. That simple it is. Because one is it is following C syntax. But the same if you want to learn data types in some other language, Pascal, Fortran and all, it will have been a nightmare. Because they follow a completely different syntax only. Clear? So Java is very easy. And at the same time it is powerful, portable, all that is there. So I'll start off teaching you data types now. Last class I started. But now I'll go more deeper into this. So data types are used for storing actually what? Values. And there are many types of values. See here. This is integer value, this is string value, like that many types of values are there. So there are so many types of value, and for all those types of value, Java is giving you immense support. That's why we say Java's data types are very, very powerful. Other languages do not give you this richness for storing what? Values. So when you can't store the value only, where is the question of writing logic, man? When any other language doesn't support you to support what? Values, where is the question of writing logic? So we opt out, means we refuse to use it, or we refuse to learn it only, first of all. Understood? So learn a language which is very powerful, and the powerfulness of a language is decided on at least some of these 8 factors. Still more factors are there, but at least these 8 factors we first see whether it is good or bad. Okay. Then other features are also there. See, this is programming feature. Then performance features are there, like memory management, portability. So everything will take into account. When you choose a language, we look into the programming support what we are getting. At the same time we look into the performance support. All that we'll see. Okay, so I'll clear all this and we'll start learning data types now. Shall I clear? I'll clear all this because I need space. So we are going with the 5th one now, that is data types. After I complete that, then we'll go to literals. So last class I just gave you some brief info about data types. So at least one thing is clear now. Data types are used for storing values. That is clear. So let's start summarizing now. So data types are used for what? Storing values. That's the first thing. They are used for storing values. Data types are used for storing values. But how many types of values are there? Next question. See, it's so neatly organized in Java, you'll start following it very easily. So neatly organized here. This is the value, use this data type. This is the value, use this data type. Clear? So neatly they are organized. Start seeing now. So data types are used for storing values. Fine. Next, what are the different types of values first? As a developer, you should know the type of values. Primitive values and non-primitive values. Or one thing I'll do, one thing. So data types are classified into 2 types. Primitive data types user defined data types. And these contain primitive value, or one more second. You see, variable declared of primitive data type. Okay, see, primitive data types are there. Primitive data types are going to store what? Primitive values. But to store a primitive value, you have to declare a variable, na? To store a primitive value, what do you require? Primitive variable. So those types of variables are called as primitive variables. So variable of primitive data type, like say, very simple example. Int is the data type. Okay, I am declaring A. So A is a data type of int, but it's a primitive data type. Understood? So a variable of primitive data type is called as primitive variable. A variable of primitive data type is called as primitive variable. And it can store what? Primitive values. A primitive variable can store primitive values. As simple as this. Primitive data types. A variable declared of primitive data type is called as primitive variable. Understood? And primitive variables can store primitive values. Very simple classification. This side. Now you don't know what is that user-defined data types in Java, especially. We'll be seeing it later. So don't bother right now what it is. But user-defined data types are called as means a variable. A variable of user-defined. We'll see how to design it first. See, this primitive data types, why they are called as primitive data types means it's given to you by the language itself. Int, float, byte, short and all, they are given to you by language itself. That's why they are called as primitive data types. It's built in. User defined means it's not built in, we create it. User defined means we create it. So primitive data types are there in the language, and a variable declared of primitive data type is called as primitive variable. User defined data type we have to define. We'll be declaring it later, like how you write a structure in C, enum in C, here in Java also we'll write. Okay, so they are called as user defined data types. We'll write in Java now. Okay, we'll be doing that later. First we'll complete this and then we write. So once you design your data type, once you design your user defined data type in Java, we'll declare a variable of that type. And those variables are called as reference variables here. So that topic I will not be discussing today. I will be concentrating only on what? Primitive data types, primitive variables. Just I am giving you info. A variable of user defined data type is called as a reference variable, and it can store reference values. Understood? Primitive data types, user defined data types, reference variables. One more is there actually. Derived types, and these are called as derived types. So there are three men totally. One is primitive data types, second one is derived types, third one is user defined. So this is one, this is two, this is the third one. Are you clear? Primitive, is it visible? Is it all the three are visible now? So primitive data types, second one is derived types, third one is user defined types. Is it visible now? Clear? Is this thing visible? Okay, so fine. So here we'll start off with primitive. See, derived types example are arrays. I'll come back. How do I put it here? I am running short of space here. All things are correct. Just to maintain it, I'll write it neatly, legibly. That's it. Okay? All things are correct. 1 second. I'll write it very clearly. They are called as primitive variables, and they can store primitive values. Derived types, Here actually they are called as arrays. Derived types are called as arrays. We'll be seeing it. Third one becomes what? User defined types. So these variables are called as reference variables, and they can store only reference values. Okay, so then I think we'll go with first primitive data types. How many types of primitive data types are there? See, how many types of primitive data types are there? Depends on the type of primitive values. Means depends on the type of primitive. Java is giving you very rich support for what? Storing primitive values. Very rich support it's giving you. Okay, but how many types of primitive values are there? So first you have to understand that. You should not simply start studying all the data types, int, float, byte and all that. There's a technical reason why they are giving you int, float, double and all that. Okay, they are giving you all those data types for particularly storing what? The different type of values. So basically you have to understand the primitive values which are existing already. Okay, and these values will be coming to you dynamically. Remember that. First you have to remember that. These values will be coming to you dynamically. So the two types of primitive values are, numeric values and non-numeric values. First you understand these two. Now what do you mean by a numeric value? Okay, again numeric value can be classified into what? Two types. What are they? Integer values and floating values. Again integer values, to store integer values means decimal values, whole number values. Integer values are called as whole number values, means one without decimal. Here these are called as floating values or fractional values. So to store these two, see the support given to by Java language. So I'll classify it here. One table I'll create: data type, size, default value and range. Data type, size, default value, range. See, so neatly I am classifying this. When you look at this one table, it's a very big table. You'll require one full page for this. So write it properly. See now how many data types has Java given to you store what values? Integer values. It is giving you 4 data types. One is byte, short, int, long. Byte, short, int, long. It's giving you 4 data types. To store what value? Integer value. So whenever you get an integer value, you can think of these 4 data types. Understood? Right now it will be hard coding, but they come dynamically. Option will be there to you. So which one to use? That's what we are going to study now. When to use int, when to use float, when to use long, when to use short. That we are going to study. Okay. So then next. Red color marker here. Red color. So the size of byte would be 1 byte. The size of short is 2 bytes. The size of int is 4 bytes. The size of long is 8 bytes. So in C also I got data types. In Java also I got data types. No doubt about it. But in C you don't have byte and all that. But Java is giving you some more extra data types. Why means they want to enhance their support, nothing else. Okay. And moreover you can see the size of int in C is what? 2 bytes. But in Java it is what? 4 bytes. Capacity is double. There it can store only what? Less numbers. Here it can store more numbers. So you can see they are very powerful. Understood? And we'll see more things. How powerful they are, we'll start seeing it. So what is the default value? Means if you don't provide a value, in other languages what happens, for any variable if you don't provide a value, it starts storing what? Junk values. or garbage values. In Java there is no question of garbage value. No question of garbage value. This is very dangerous, this garbage value. Why you know? Because when it will compile, during runtime you will start getting problems. So that's why since you get problems, garbage value always creates problem during runtime. Java does not have the concept of what? Garbage only. So that powerful they have made this data type. Okay, so all have default values. Means if you don't give a value to this, they'll be taking it as what? 0. So blindly you can predict now. What is the value in it? In C you can't predict only. If you don't give a value to a variable, you can't predict what is the value it is having. Here it is very easy to predict. It will have the default value of 0. We'll see range. Okay. So now this idea we have got little idea. Last class also I had explained the same topic, but we had to discuss one more thing. See, if you want to store a value in a variable, I told you this formula. What is the formula? Type of value, range of value, and third one is size of value. If these three things are correct, then only the value can be stored into a variable. Remember this. First is type of value. Means if you are having integer value, no, you should use what data type? These 4 data types only. Any of the 4. Then will depend what? Range. Then will depend range. Then will come what? Size. We'll discuss all that. One by one we'll start discussing. So first, you understood what is type of value now? See, if I want to store a character value, I cannot use what? These data types. Understanding what is the type of, I'll give you examples here now. Last class we had done most of this. Public static void main. Say I want to store a character value. I cannot use what? Or let me not use character. I'll use floating value. It will be easy for you. 125.98. This is what? Fractional value. Can I store it in int or any of these 4 data types which I thought you know? Not possible. So you'll get error now. Byte A is equal to, you'll get the error. Why? What is the problem here? Tell me the problem, sir. Here the problem is type of value. Here you are getting the problem because see the first case you are getting a problem because it is type of value. Now one more example I will give you. Next, range of value. See, byte A is equal to 130. It is outside the range now. What is the range of byte? Minus 128 to plus 127. This is the range. Last class we discussed this. 1 byte means 8 bits. 8 bits means totally if you put all the values there, it can store only 256 numbers. 256 numbers. Which are the 256 numbers you can store? Range starts from minus 128 to 127. See, 2 to the power of 8 numbers it can store. 1 byte as having 8 bits means it can store 2 to the power of 8 numbers. So it can store 2 to the power of 8 numbers. You only calculate, it will become what? 2 into 2 into 2 into 2 into 8 times you do. Automatically you will only get the answer. 2, 3, 4, 5, 6, 7, 8. So it can store totally 256 numbers on byte. But range is from minus 128 to plus 127. That's the range. Okay. So this is what now? Outside the range now? Is 130 within the range of minus 128 and 127? No. So here what problems you'll get? Range of value. I'm just giving you examples. If all these things are correct, then only you can store the value into a variable. So this is very, very crucial. We are seeing it in simple programs now. Okay, we are seeing it in simple programs. As the programs become bigger, you should not make such mistakes because values will get dynamically. And you should know exactly what value you are getting and which data type you use to store the value now. And you cannot make mistakes there. Here it looks simple because it will hardly 1 line, 2 lines of code. What is the importance of this? You will understand practically in what? Applications only, because there will be getting the values dynamically. Done? The third one now, what is it? Size of value. See this. Int A is equal to 5. Byte B. Now A is equal to, sorry, I want to give the value of A to B. See, int A, value is what? 5. But it is stored in 32 bits now. 5 value is stored where? I'll be showing you very clearly. Just understand all the problems. 5 will be stored in 32 bits now. Can 32 bits put into 8 bits? So here what is the problem? Size of value. Range is correct, it is within range. See, and 5 is within the range of 128 and 127. 100% it is within range. Type of value is also correct. What is the type of value? Integer value only. So integer type of value is correct, range of value is correct, but the problem is size of value. So these three things will come into picture when you are storing a value into a variable. If all these things are correct, then compiler compiles. That is very important in Java. That's why it is called as strictly type checked. Type checking will happen. What value is getting stored in what variable, type checking will happen. Otherwise, if this checking doesn't happen, when will the problems come now? Runtime now. In C, this checking will not happen, and these problems will arise when? During runtime. And what happens? Your program starts printing junk values. Something it starts printing, and you have to do what? Restart your computer. That's a big headache. Here, at least all your problems are resolved. Runtime problems are getting resolved when? During compilation time. This is such a powerful feature of Java, you believe it or not, later on you'll understand how powerful this is. Why Java is so strictly type checked, here you'll not understand. Okay, later on as the course progresses, you'll understand why Java has been made so strictly type check language. Very, very strictly type checked it is. Type checking means what value you are giving to what type of variable. Type checking means what type of value you are giving to what type of variable. It checks at compilation time. That is what is called as type checking. Clear? Any questions here? Okay. So I'll start seeing now one by one all the things. Okay, how to store value and all that. Just I give you an overview now. Clear? So now let's see. Calculate range now. We'll come to byte now. I start teaching you byte data type. And you see, okay. Yeah, byte is 1 byte. The size is 1 byte. That is equal to 1 byte is equal to 1 byte itself. Means byte data type will have 1 byte of capacity. Byte data type has 1 byte of capacity. 1 byte of capacity means 8 bits. So now see this. First clearly understand the program here. Byte A. What are you doing here? Exactly what are you doing here? See the program clearly. Step by step you start seeing it. Yeah. First understand the basics here. You are declaring a variable. But you are declaring what type of variable? Byte variable. Means you are declaring a primitive variable. Understanding now? What are you doing here? You are declaring a primitive variable. Why are you declaring a primitive variable? Because you want to store a primitive value. What is the primitive type of value you want to store? Integer value. But I want to store the value within the range of -128 to 127. So I choose byte. As simple as this. So byte A, you are declaring a variable. Next, A is equal, see this is declaring a variable. A is equal to 5. What is that you are doing now? Assigning a value. So this is the syntax. If you want, you can write it in 2 lines. Or if you are interested, you can write it in single line also. Byte A is equal to 5 can be written in a single line. A lot of things happen in this line. You are declaring a variable A of type byte. Now variable means what? Memory allocation. You are declaring a memory location. And after declaring it, you print SOPA. It will give you error. It says variable might not have been initialized. But in C what happens? You will get junk value. That is not here. It says variable might not have been initialized. Please give the value. It will tell you clearly. Because you are not declared and initialized now. But here if you say by SOPA, what happens? It will print. Understood? So byte A, you are declaring a variable. Okay, but still only memory has been allocated. One variable is there, that's it. It's a named memory location. It is not having any 8 bits has been allocated now. Like this. But there is no value. If at all you want, you can give the value. 1, 2, 3, 4, 5, 6, 7. No. 1 second. Only variable has been declared. That's it. It's a named memory location where you can store a value. In the JVM, A is there. That's it. In your JVM, A is there. It's a named memory location. It shall store a byte value. Now I'll say SOP 8 gives me error. There is no value in it. A is equal to 5 now. What will happen? 8 bits of memory gets allocated. And 5 will be stored like this. 0, 0, 0, 0, 0, 1, 0, 1. Clear now? Binary format. And after that, if you print SOP A, it prints 5. So now once you declare a variable now, you can use it any number of times. Once you declare a variable, you can use it any number of times. I want to give a value of 7. Fine, give it. And print now again. It prints 7. Now what happens? When you say A is equal to 7, one more new memory gets allocated. And you know how 7 is represented in binary? 111. So it will now not refer to this. A will be referring to this location. This value will be lost. It overwrites. And this is where you have to be very careful now. And anyway, this is related to operators. Still, operators topic is pending. I'll be teaching you more about operators. That time I'll teach. But this is called as assignment operator. And it is a very powerful operator. What it does is, it takes the value from the right hand side and gives it to the variable to the left hand side. Blindly it will do that. It does not bother. Whatever value is there on right hand side, it takes it and gives it to the variable to the left side. It overwrites. If you want to take one more example, I'll write here. Byte A is equal to 7. Byte B is equal to 0. B is equal to A. Earlier if I print SOP AB, it will print what? It will print what? 7 and 0. But now if I say B is equal to A, what happens? B was earlier having a value of what? 0. Now it overwrites. So the value can be given directly like this also, or it can be given from a variable also. See, A is on the right hand side now, but it is treated as value. So they both are variables only. A is also on variable, B is also on variable. But which variable is on right side, it is treated as what? Value. Which variable is on left side is treated as variable itself. Okay. So now if you print SOP A, B, it will print what? Both will print 7 and 7. You should be very, very careful with this. And here also compiler checks what type of value you are giving to what type of variable. Understood? It is very powerful and it checks during compilation time only. Because in C now what will happen? It will compile. During runtime will start getting problems. Some value will give to some variable and a lot of problems will start happening later. But here all that problems will not happen now. Are you clear with this? Clear? So this is one example, this is another example. So first A and B were having values. I'm not saying no. Or you take it as B is equal to 5. A is having value of what? 7. B is having value of what? 5. Fine. SOP AB what it will print? 7 and 5. Later on you change the value. The value of A is given to what now? B. So B will be what now? 7. The value of A is given to B. Okay, so here it will not check for equality. For equality, checking equality, there is one more operator called as what? Comparison operator. Anyway, operators is one more topic which I will be teaching later. See, there is a difference between this and this operator. This is called as assignment operator and this is called as comparison operator. So they are two different altogether. Don't get confused. I will be teaching you operators later. Clear? So it assigns the value from right hand side to left hand side. Are you clear with all this now? Okay. So the size of byte is 8 bits and it can store only 256 numbers. Range is from so and so to so and so. Now what happens if I try to store a value outside the range? Next question. What happens if I try to store a value outside the range? It cannot store. And it gives error when? Compilation time. I showed you now. Shall I clear all this now? Okay, let's come back to this program itself now. So I will write now byte A. I will declare it SOP A. It will not give print. It will give me error. Variable night not initialized. Try it out. Now A is equal to 150 or 138. Take simple. For you it will be easy to understand. Is it within the range now? Where is the range? Okay, what is the range now of byte? This is the range. Is 130 within this range? What will happen? It cannot store. It cannot store. And when this problem is reported? Compilation time. See, that powerful compiler is. During compilation only it checks, are you giving the correct type of value to correct type of data type, correct type of variable. It will check it during compilation. Very good, this one. Otherwise what will happen? If it in C, it will compile off blindly, and during runtime you start getting some junk values. These are problems, but Java is very strictly type check. Type checking means what? What value stored in what variable will be checked during compilation type only. Clear? So this is error. But still, if you want to store, what you should do? You have to do something called as casting, type casting. Okay. So this will not work now. This will also not work. So that time you say A is equal to byte of 130. So when it is outside the range, what we do? 130 will be converted to byte. If you want the syntax for this, the syntax here is, it's very simple. Here it is called as target type. I will be teaching you typecasting later. 1 second. This is called as destination is equal to target type. And this is called as source. Source is this. Target type is what? Byte. Destination is this one. Means convert it and then put it. As simple as this. That's the syntax. This is the syntax. This is the example. But I will be teaching you typecasting in depth. Source. So what it will do? 130 will be converted to byte. How it will be converted to byte now? Means it starts swinging. So from 127 it swings towards the negative side, and again means 127 numbers over. So how many more numbers now? 3 more numbers. Means minus 128, minus 127, minus 126. So the value in B would be minus 126. It swings. Understood? SOP A will print minus 126. I showed you this in the last class. Are you clear with this? How it swings? So supposingly if it exceeds 256, what will happen? Modulo ratio will be applied. Supposingly if it, I showed you, no? See, if I say A is equal to byte of 135, what happens? Still it comes positive side. How many values more? 5 more, no? Means it will become minus 121, I think. Like this it comes now. See, it will move 127 numbers, it will move this side. Then what it does? It comes to negative side and starts looking for what? It will start counting like this: 128, 129, 130, 131, 132, 133, 134, 135. 135 will become minus 121. As simple as this. So here if you print SOPA, it prints minus 121. And actually what this syntax means is, see, default, if you write like this, A is equal to 130, compiler will not allow you. It says, hello boss, check the value, what you are giving. Like that it wants you. Understood? But here what you are doing? You are telling the compiler, I know it is of type byte. Understood? And I want it to be converted of type byte. I am the person responsible now. Now you don't take responsibility. I am taking responsibility to convert that to this type and store it. So you don't bother. I want this to be done, do it. You are instructing the compiler. So that's why you will do this casting. I will be talking about typecasting later in detail. Okay, so here compiler will not allow you, but here compiler allows you because you are telling the compiler, please allow me to do this. But here what will happen? Loss of data will happen. If the value is outside the range, definitely loss of data will happen. If the when typecasting is done now, and if the value is outside the range, loss of data will happen, and you cannot expect the same type of value. Same value you can't expect. Definitely there will be loss of data. Not only in Java, in all languages this is the same story. Understood? In all languages this is the same story. In C also it will happen. Same story, in C also. Try it. You try to give, see, in int I, in C is what? The range is minus 32,768 to plus 32,768. You give. It will blindly compile. But when printing it will give you some value. In C what is the problem? Check this out. Int I, the value of I in C is in the range of what? It's 2 bytes. So minus 32,768 to plus 32,767. You give something like 35,961. It will compile. Blindly it will compile. No error only it will give. But when you start using it in the output, print fi and all, or when you start using in addition, subtraction and all that, there's some other answer only you'll be seeing. You get confused now. But Java does not allow that. If such a kind of value is given, it tells you during compilation time itself. Please check what are you doing. But still if you want to store, then we do it like this. Explicit casting will be done. Clear? So So in all languages, when the value is outside the range, we lose data. In all languages. Java is no exception. So almost all it is following the same rules of other language. But it has made it more powerful. How powerful we'll start seeing now. This is the first data type. Yeah. One is it is strictly type checked. That is why it's called as powerful. Any questions here? I'm completing byte and the range of byte is what? Minus 128 to plus 127. Okay, still if I exceed A is equal to byte of 260, what happens? 127 numbers plus means 128 numbers plus 128, 256. So now it starts moving towards positive side. 1, 2, 3, 4. So it's totally it counts 256 numbers. How it counts? First positive side, then negative side, then positive again. So it starts counting like this. And SOP I will print you 4. But don't think always it will be cycling like that. It will apply the modular ratio. Once the value exceeds 256, it will apply modular ratio. Internally, which one? The JVM, the runtime system, what it will do? It will do like this. It will take 260 now, you want to store, fine. How it will convert? See now. See, below 256, it will do positive, negative and all that swinging it will do. But once it exceeds, how many times it will start swinging now? Positive, negative, positive, negative. So what they will do? They will apply modulus ratio, 4 is the remainder. Now they start counting 4 numbers, that's it, it will store off. When the number is big, that time they start applying modular ratio, because unnecessarily they will have to start swinging positive, negative, positive. So to remove that cyclings, they will do the modulus ratio. Internally it's happening. Java runtime system or JVM is doing this. Implicitly it will do this. Are you all clear with this? Do you have any questions till here? Last class I had completed till here. Still you have doubts, you can ask, or I'll move to the next data type. Typecasting I'll come back. I'll come back to the subject of typecasting. It's not over. It's a big subject. I'll give notes and then I'll teach you. Okay. But the int is, you know the behavior of byte now? Byte behavior you understood? So if your value is within 127 and 128, this is how it will work.
Sir, if you are applying modulo operation, so always output will be so the result will be positive.
It can be negative also, no? It depends on the type of value. Minus 256, minus 260. What is the remainder? Minus 4. Student type. His question is, if I give, whenever I apply modulus ratio, always what will be the value? Positive value. Okay. I don't know how you are putting the question. One is this way. You check, it will become minus 4. Other way is, you do one thing. 256 plus you add 130. 6 plus 0 is 6, 5 plus 3 is 8, 2 plus 1 is 3. Now you will find a negative value. 386. How it will become positive always? 1s are 256. What is the remainder? 130. How is 130 stored in byte? Minus 126. Understood? No? You can type it. One is, see, the source only can be a negative number. Like you can say minus 130, what is that? Minus 260. I know where I wrote now. Yeah, one is you can say minus 260. Or you can tell, sorry, minus 386. Now this will be a defined output. It will be positive side, think. Just go and check it out. You will only understand. Clear this?
Sir, since we have the minimum value as 0, and if we just declare byte, the variable name, won't it take the minimum default value?
Yeah, his question is, he's having a valid question. I was talking about default value. When I declare simply byte A, why it is not taking the default value? Understood? There are some 3 types of variables in Java. Local variables, instance variables, static variables, which I have to discuss in depth later. Right now we are discussing local variables. Okay, right now we are discussing local variables. So for local variables, it will not take any default value. You have to give the value for local variables. Local variables means which is there inside a method. Any variable you declare inside a method is called as local variable. Understood? Any variable which you declared inside a method is called as local variable. Local variables do not get default values. Only static variables and instance variables get default value. That topic I'll take later. So that's why I can't teach you default value right now. I'll be teaching it to you later. Default values I can't teach you later. Now, right now I can't teach. I'll be teaching it to you later. Okay. So this default value concept comes when you are dealing with instance variables and static variables. Okay. But whenever you are declaring a variable, local variable also, okay, make it a habit. You only make it a habit. You have to exclusively do it. A is equal to 0. You give it. You make it a habit. So local variables do not have values, default values. But when you think that some value has to be given, some value at least, instead of directly saying byte a is equal to 5, because later on it will get a different value now. So instead of giving something like byte a is equal to 6, 7, 8, what you do? Give a value of byte a is equal to 0. Understood? You give the default value. Understood? I'll be discussing about that also. Clear? So now we'll see the range. And see, there's one more way to write the range. Instead of writing minus 128 to 127, to make it easy for us, we write it in this way. End of the day, value is same only. See, we write it like this. Minus 2 to the power of 8 minus 1 to 2 to the power of 8 minus 1 minus 1. Correct, no? What is 8 minus 1? 7, no? Minus 2 to the power of 7 is how much? Minus 128. And 2 to the power of 8 minus 1 is how much? Again 128 minus 1 means 127. This will be more easy for you to remember. So range can be written in two ways. We can write it, means for us to remember we do like this. See, it is minus 128 to 127. All of us know that, but also I can write it like one more way, range. To remember we write like this. 2 to the power of 8 minus 1 to 2 to the power of 8 minus 1 minus 1. Same I have written, what I have written here, I have written it here. If you are not seeing it clearly. Yeah? Okay, next either this or this. See, this is very difficult because see, for byte you will remember. For short, int, long and all it becomes difficult. There will be very big numbers. Okay. So for byte it will be 2 to the power of 8 minus 2 to the power of 8 minus 1 to 2 to the power of 8 minus 1 minus 1. This is for byte. Now for short, can you guess what it will be? Minus 2 to the power of 16 minus 1 to 2 to the power of 16 minus 1 minus 1. As simple as that. Int will be minus 2 to the power of 32 minus 1 to, following now? Last one is long. Minus 2 to the power of 64 minus 1 to 2 to the power of 64 minus 1 minus 1. Following up? Same values you can write here. Or you can write like this also. See, short is minus 32,000 range 768 to plus what? 32,767. 2 bytes. 32,767. Or you can write like this also. 16 minus 1 to, getting it now? It is easy. So 32 minus 1, 32 minus like this. See, now int I can't write, it's a very big range now. So you calculate now. Long also I calculate. Okay, but still I'll continue teaching you some things about short and byte. That is range. That is range. But let's see how to work with short also. Shall I clear all this now? Yes, if at all you want to store an integer value, what will I do? I can use short also now. Valid. Short, yes. SOPS error. Why? It's a local variable and it is not been initialized. Okay. So better you give the value of 0. Always you take the initiative to initialize the local variables. You take the initiative. So SOP is 0, S it will print 0. But now S is having what value? 0. But how much of memory has been allocated? 2 bytes means 16 bits. Memory has been allocated as 2 bytes or 16 bits. Okay. So 2 bytes or 16 bits means what now? You can store how many numbers? 2 bytes means how many numbers you can store? 2 to the power of 16 numbers. Sit and count now. 2 into 2 into 2 into 2 into go on counting. 16 times. So totally it will come up to 65,536 numbers. So you can store these many numbers in a short. Range is what? Minus 32,768 to plus 32,767. Now what rules you studied for byte, same rules are applied here, no change. So if at all you want to store an integer value, it should be in short, it should be within the range only. Now say S is equal to 5, valid, SOPS 5. Compiler checks what is the type of value, integer value. Next is what, range of value, correct, size of value, correct. So all it will check and it will store it. Next I want to store s is equal to 99, fine, SOPS it will print 99. If you want to store negative value, s is equal to minus 129, SOPS is what, 129 only. So it is within the range. Okay, but if I exceed the range, s is equal to 35,921, compilation error. So again you have to do what? Typecasting. So you have to bring it within the range, because the type of value is correct, range of value is correct, size is the problem. So you have to convert. How you do it? S is equal to short. You know the syntax now? Source, target type, destination. So give the value. So you know how it works now. Positive, negative. If the number is too big, modulus ratio of. If it is crossing 65,536, then it will apply modulus ratio. Understood? Just to avoid cycling, that's it. Yeah, same rules gets applied for short also. But the capacity of this is what? 65,536 numbers, and range is this much. So if you are planning to store an integer value within this range, you can use short also. Clear? So next is int. Range is, you understood not? Minus 2 to the power of 16 minus 1 to 2 to the power of 16 minus 1 minus 1. This is base. This minus 1 is base. Yeah? So shall I clear this now? Int, let us see. Let us see int. I'll finish off everything and then we'll see. I'll type and show you. Now int is very big, unlike C in Java. See, in C it is having what? 2 bytes. Means you can store only this much. Now nowadays, does 32,000 have some value? When C language was developed in 1970, 32,000 was a big denomination. But today, what do you mean by 32,000? Nothing. No value only for 32,000. Your salary is 32,000 today. Now company's turnover will be how much? So if you want to store such big values, so you need big storage area. So that's why they doubled the capacity of data types in Java. Java came in 1990, no? So they knew bigger denominations are coming. So they made their data types more powerful. Understood? So that's why the capacity of int has been doubled in Java. 4 bytes they have made. And you know the range now? You know the range now? Very big range. Okay, now I can't sit and calculate numbers and all, you decide now. How many numbers? 2 to the power of 32 numbers. Negative side, this one. This is the range. Positive side is this one. Now double in Java is what? In C is how much? 4 bytes. Double in Java is what? 8 bytes. Tell your denomination, it can store here. What is your denomination? Java can store it. Easily it can store the denomination. You don't have to worry about what your denomination is. Still it is very big, you got what? Double. There also you can store. Understood? We'll see that also. So this is how it has been done. Are you clear? Okay. So one more thing, let us see this now. Sometimes, see here, this is the value I want to store, 1, 2, 3. But I want it to become, it will by default it will take it as what? Integer value and store it. But I want it to be of type double. Sorry, I want it to be of type long. I want it to be of type long. So that time what you can do, you can add the suffix L. See if it is 123, I can store it in what? Byte, short, int, anywhere I can store. Correct now? It is within the range, I can store it anywhere. But by chance, I want it to be strictly stored in long only. I don't want byte to be used here, short to be used here, int to be used here. I want this value to be stored in long only. So I can enforce it to follow what? Long rules. By just adding one suffix L. Capital L or small l, no issues. Both will work. But now this can be stored where? Only in long. If you try to store it in int, it will give you error. Because it's of type long. You can enforce it. Sometimes there will be a requirement. Okay, you want it to when you are having a value now, you want that value to be stored in long only, but not in any other data type. That time you can enforce like this. Value will be there, but it's within the range. But I want to store it in what? Long. Okay, 123 is a value. I want to be stored in only long data type. See, if I say 123 and say byte A, it will store now. Yes or no? But I don't want this to be stored in byte also, short also, int also. So what will I do now? Just add L. Finished. It will give compilation error. The value will be taken as long value. It enforces. Okay, and now you have to use long only for storing this value, long data type only for storing this value. Clear this? I'll type and show you all this, whatever I discussed. One by one we'll type and see. Are you clear with all this? Okay, now I'll move to floating values, fractional values. I think before I move to fractional values, one small thing I'll talk about how negative numbers are stored in Java. I am the main trainer. I am itself telling you this is not very important. But just for your curiosity purpose, I'll teach you. Don't bother how positive numbers are stored, how negative numbers are stored in Java. Just it will be helpful for you somewhere down the line later, where that time you see, but really not important for you in interview and all that. Just understand how negative numbers are stored in Java. So first I'll show you how positive numbers are stored. Byte A is equal to 5. Let's see how it is stored. So A is there now. So A 5 gets converted to what? See, everything in computer gets stored in what? Binary format only. So first 5, this one will be taken. 2 2s are, remainder is 1. 2 1s are. So this is the value. So byte means I'll show it in byte. Same rule gets applicable for what? Int, long and all that. But there I have to write 32 bits. Since I cannot write 32 bits, I'm using byte here. Okay. So 0 0 0 0 0 1 0 1. These are positive numbers are stored. Clear it is. No doubt about this. But let's say how negative numbers are stored. So these are positive numbers are stored. Understood now? These are positive numbers are stored. Now negative numbers. Negative numbers. How they are stored. Okay, that's how positive numbers are stored. I don't have space here. Okay. How are negative? Same. And if I print SOP, it prints fine. No issues. But if I say same, I'll comment all this and I'll say byte A is equal to -5. How it is stored. So what happens if you 0 0 0 0. I don't have space here. Where to write? I'm finding it. I'll clear here itself. How positive numbers are stored, you know that very well. Now let's see how negative numbers are stored. So when I say byte A, so this is how positive number is stored. Positive 5 is stored. Negative number, let's see. What will happen now for storing negative numbers? First, see, Java uses 2's complement. Java uses 2's complement to store what? Negative number. That's all you understand. Don't bother much about this now. Positive numbers, you understood how they are stored. Let's see how negative numbers are stored now. This is the topic. So now let's see. So first, this will be inverted. You invert. Positive 1 you invert. What will it become now? This is how it is inverted. So first step is see how negative numbers are stored. First step, what it will do? Inverts the binary value. This is the first step. Now steps for storing negative numbers. Steps for storing negative numbers. First it will invert. Second step, it adds 1. So it's using 2's complement. See this. So if you add 1 to this, what is the result? 0 plus 1 is what? 1. Then, so after adding plus 1, this is the result. See, this is step 1. This is step 2. Then step 3 is what? This is how it will be stored now. Adds 1, it will store in the memory. After adding, this value will be stored in the memory. So how is a negative number stored? First it will take the value, positive value, whatever it is, 101, no, it will invert it, this value it will get. After getting this value, next step what it will do? After inverting, first step is inverting, it will add plus 1. And once plus 1, whatever the result you are getting, this value will be stored in what now? A. So A is containing this value. Clear with this? A is containing this value. Now if you want to get the value, what will they do? See, it's using 2's complement, man. You know what's 2's complement now? So when you want to get the value, what it will do? It will start decoding now. How it will decode? All the ones will be converted to what? 0, and 0 will be converted to 1. So this is how it will get the value. Now this is retrieving value. So it will convert what? When it is getting the value, so this is how it will get it. It will invert again. It will decode it like this. And now you find the decimal value of 100, it is 4. After getting that value, what it will do? It will add with plus 1. As simple as that. So after it gets the decimal value, its decimal value will be what? 4. 2 to the power of 2 is how much, pen? See, it becomes as simple as this. 2 into 2 to the power of 0. So see, if you want, you convert into, how do you convert a decimal, binary to decimal, you know, no? How do you convert a binary to decimal, you know? So it is as simple as this. 100, if you want to convert, what will it be? 1 into 2 to the power of 2 plus, sorry, yeah. 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. So 1 into 2 to the power of 0 is how much? Sorry, this is 0, no? See, 1, 0, 0. 0 into anything is what? 0 only. 0 into anything is what? 0, leave it. But 1 into 2 to the power of 2 is how much? 4. The result is 4. You add plus 1. So it will become 5. Then it will put minus and print it. So it is basically using 2's complement. That's all you understand. Do not bother much about this in Java. But in C, negative numbers are stored in a different style. But in Java, negative numbers are stored in a different style. So the value is same only. See, you have the basic thing what you have to understand is, there are so many languages in world. Value will be same, but the way they are stored in memory will be different. Like how phi is stored in Java environment is different. Like how phi is stored in Pascal environment is different. How phi is stored in COBOL environment is different. That's what you have to understand. I'm just comparing it with C language. But in every language, this is going to change for you. Yeah? In Java also, negative numbers are stored like this. It just uses 2's complement. So while storing, what you do? Invert and add 1. This is the value which will be stored in the memory. So this is A. A will be having this value. So when you want to retrieve the value, what will happen? It will again, first step is what? Inverts again. After inverts and converts to binary. Sorry, converts to decimal value. After converting to decimal value, what it will do? Second step, add 1. That's it. Invert, convert it into decimal value, then it will add 1. That will be the final answer for you. 2 steps. That's inversion and adding 1. That's it. Clear this? Okay, then I'll go with floating values now. I don't have space here. Sorry, decimal values are floating values, no? Now to store these 2 type of values, Java is giving you again 2 data types. Again the same story will start here also. Data type, size, default value, range. And there are only 2 here. Can you guess? Float and double. Float and double. We'll write the range. First we'll finish off. Size is what? 4 bytes. This one is 8 bytes. Default value will be 0.0. This also will be 0.0. Clear? Default value. Next is range. Range, I'll write it off. Range I'll write here, then I'll again write it here. See, for float, because it will be visible. If I write here, it might not be visible for you. I'll write it here first. Float range will be 3.4 E minus 308 to 3.4 E 308. I'll explain what is that, don't worry. Double is, one second. 3.4 E minus 38 to E 38. Double will be 1.7 E minus 308 to 1.7 E is the range. A very big range, man. I'll explain what is that range. It's the range. Means what number you want to store in Java, it is possible. Whatever number you want to store in Java, it is possible. See, clearly understand, this is the support Java is giving you to store any type of value. No language gives you this support. Pascal, Fortran and all, they failed only because of this reason. Java is very, very, very powerful. At the same time, it is user friendly. In one day we are finishing how many data types? I'll finish 8 data types. In no language you can't learn 8 data types in one day. To learn one data type, you will take one day in other languages. But in Java, in one data type, you can learn what? 8 languages. That user friendly it is. Clear? So anyway, just because you are seeing it first time, or I don't know, but it might be looking somewhat awkward to you, but I'll explain it to you, it will become easy. So that's the range. That same value I'll write here, 3.4 E 308 to minus 308 to what? 3.4, the space is the problem, man. 3.4 E minus 38 to 3.4 E plus 38. (1.7 E minus 308 to 1.7 E 308 positive. So this is the range. Okay. So now we have come to store what? Fractional values are Richard? Sorry, what mistake I'm doing, man? This is decimal only, no? Okay. Decimal only, no? Decimals have oh, this is real number values. Fractional values, no? Oh, fractional values. This is decimal. Okay, we'll see this. Floating values, fractional values. Okay, then next we are coming to this now. See, this is the range. See now, first of all you have to understand floating values are of two types. Floating values can be of two types. Floating values can be of two types. Okay, one is single precision value. First the value you understand, then we'll understand which. If you understand the type of value, then you'll understand which data type to choose. Single precision, then the next one is double precision. Single precision, you know what it is? They are not very accurate. Single precision is not very accurate. Double precisions are having high precision, or they are having high level of accuracy. These are the type of fractional values are floating values. Clear? So fine. These are the two types of floating values. There are two types of floating values. There are two types. This is types of floating values 1 and 2. Then now floating value can be stored in Java in two ways. Storage, now you can do it in two ways. These are the type of values, but you can store these two types of values in two ways. How? storing float values can be again done in two ways. What is that? See, understand the difference. This is type of floating value. Understood? What are they? Single precision, double precision. Now, this value, whether it is single or double, you can store it in what? Two ways. Storing floating values can be done in standard notation, and the other one is also called as scientific notation. These are the two ways you can store it. Scientific notation is also known as exponential notation. Both mean same. Scientific or exponential both mean same. So first I'll show you single precision standard notation. Now once again, first I'll write on program, then I'll teach you this. See, I want to store a value like this, 125.93. This is the value I want to store. By default, this value will be taken as what you know. Now, what is the type of value? Floating value. So remember this rule. Type of value, range of value, size of value. Type of value is what now? Floating value. You want to store it in on data type now. These data types will not support now. So you have to use which data type now? Floating, these data types you have to use either float or double. Fine, among this, okay, see here what is happening is type of value, you realize what it is. But it is of type double precision now. It is of type double precision. Double precision means very high accuracy. So the problem is now a type of value only. It is floating value, but the type of value is double precision. It is floating value, but in type of value also how much are there? Single precision, double. It's double precision. Now you cannot put double precision value into what? Float. So if you try to write the code like this, it gives you error. It will not store. It will give you compilation error. Compiler is checking, you are trying to give a wrong value to wrong data type. So to enforce that, you give what? Single precision value to this is, you have to add one suffix f. F can be caps or small, no issue. Either caps or small. Now it will become single precision. Now it will store. Now it is within the range. See, first is type of value. What is the type of value? Floating value with single precision. It is floating value with single precision. Next is range. Range is correct. Size also is correct. It is 4 bytes. Size is 4 bytes. It will take it as 4 bytes and it will store it. Are you clear? So you have to add suffix. One way of storing floating values like this. Either you add suffix f, or other way you can write is float f. You can typecast. Generally we avoid this 125.93. You can write the code like this. You can typecast, but this is more easy to do. It's more easy to do. Means end of the day, see, you are trying to store what? One type of a value, a double precision value into float value. If you want to store a double precision value into this one, either you typecast or you enforce it like this. Two options. Okay, but we generally prefer this approach. Typecasting I have not completed. After typecasting you will understand that. Clear? So just add f and you can store a floating value. Clear? And you can store a floating value and you can work with this. So this is called as what now? Standard notation. Okay, but the same value if you want to store it in double, see, it is very easy. Double d is equal to 125.93. Perfect, it is double precision. It can be stored. Understood? So first I'll finish off with float, then I'll go with double. First I'll finish off with float, then I'll go with double. Just I showed you a little difference between float and double. Now float we'll start studying. See, if you want to store a floating value, compulsory you have to add what? F. Because if you don't have add f, it will be taken as double precision. So in float data type, you can store only what? Single precision values. In float data type, you can store only single precision values. You cannot store double precision value. And how do you make it single precision? By adding f. That's it. Clear? Any questions? Nobody uses float, don't worry. Most of the data types you don't use it. We'll see it later. Now next, double. Double will be storing in what precision? Double. Okay, for 1 second I'll finish off with float. See, when do you use float is when single precision means, what do you mean by single precision? Like examples I give you. Some like room temperature, 39.7 degrees centigrade. 39.7. So here you require what? Less accuracy. See, when you want less accuracy, float f is equal to, or float temperature is equal to 39.8 8. Here you require less accuracy. So use single precision. Over. You are talking about currency, amount, float amount is equal to 100 rupees 39 paisa. Fine. Single means you don't require too much of accuracy here. So that time you can go for float data types. Okay, you don't require much of accuracies. You require the precision what you require is very less. So when you require very less precision, you can go for single precision. But sometimes you require too high precision, too accurate precision. Understood? Too accurate precision or you need very high level of precision. So that is when we start using double. Shall I continue double now? Example. See, there is pi, double, pi. You know pi, no? 3.1416. Now double radius is equal to 10.598. This is what? Radius. So I want to multiply these two. Double area is equal to pi r square. You know that, na? So you require very high accuracy here, very high precision. So that is when you can go for double. Understood when to go for float and when to go for double? Here very high accuracy is required now. You don't want to lose any decimal value here. So that is when you can go for double. Now again this can be, double value can be represented in what? Standard notation and scientific notation. So I didn't teach you scientific notation, no? I'll cover that now. Are you clear with this? What is what is that? Single precision value, double precision value? You are clear with single precision and double precision. Next I have to show you what? Scientific notation. Okay, I'll show you that. Shall I clear all this? Clear? I'll clear all this. Result you can calculate now. You print SOP area is, let's say you print. Or I'll show you if you want. See, one way you can store floating value is like this. This is standard notation. This is standard notation. One more example I'll show. This is double A. Or you can write A is equal to 75,000. Like this also you can write. Double means you can write like this. Same you can overwrite like this. This is called as standard notation. If you want, you can store it in scientific notation also. The same 75,000 can be stored how you know? D is equal to, can you guess? 7.5 E what? 10 to the power of 4. Or it can be also written as 75 E 10 to the power of 3. This way also you can write. Both are correct. So means you are only telling 7.5 into multiply 10 by 4 times. 10 into 10 into 10 into 10 or 10 to the power of 4. This, if you want the clear explanation for this, it is called, this is the syntax here. The syntax if you want, let's see, I'll write it here. The syntax for that is mantissa. You know what is mantissa? Mantissa E exponent. So 7.5 is mantissa. E you have to use. E can be caps or small, no issues. You can write E caps or small, no issues. And then exponent, what you want. 75,000 can be written like this also. Okay. Or you can write 750 E 10 to the power of 2. This is also valid. It's up to you. Okay. But the same thing, say if I want to represent this value, 0 point, how will you store now? You can write like this. See, this is one way. This is about what? See, I need very high level of precision here. Either it can be a which one? Either I can have a value like this or I can have a decimal value like this also. So when you need very high level of precision, we start using double. So D, I can store it, no issues. But the same can be written what? D is equal to 7.5 E to the power of what? 10 to the power of what? Minus 4. As simple as that. You can write like this also. Understood? D is equal to 75 into how much? 10 to the power of minus 5. That's up to you. These are all correct. You can write like E means 7.4 into 10 to the power of minus 4 also, or like this. Okay. So now one more negative number you'll start seeing. These are both positive numbers. These are both positive numbers. Okay. So these are both positive numbers, but now we'll see negative numbers. See, I want to store a value like this. Minus 0.001. 00075. How will you write this now? You can write like this, no issue. Or the same value can be written as what? D is equal to minus 7.5 e to the power of 10 minus 4. Correct now? Are you following? This is equals, this is minus. The syntax is here, mantissa e exponent. Minus 7.5 is mantissa e exponent, 10 to the power of minus 4. Imagine what big ranges you can store now and what big accuracy you get here. So there is no loss of data in Java. What type of a value you want, you can store here. Isn't this a powerful language? Very powerful now. You tell your value, it will store. In C, where you got the support? You don't have only. Understood? So single precision values, double precision values, scientific notation and standard notation. Very high level of data you can have here, store here. Any questions here you got? Now I'll teach you typecasting. Understood? Now I'll teach you typecasting because we'll convert all the types. Now we'll clearly understand. Or I think first, I'll complete off non-numeric values also have to complete, and after that, fine. First I'll complete off non-numeric values also, then I'll teach you typecasting. It will become very clear to you that time, typecasting. Now only I can do, but you'll not have clarity. So after I complete all the data types, then I'll teach you typecasting. Clear? It's only flow, man. After what should come? After what should come? Because that will give you more clarity. Do you have any questions here? Shall I clear this now? But if you want to store a single precision value, add F. That's it. Which one? Caps are small. And if you want to store it in scientific notation also, add E. See, this can be caps or small. Minus 7.5 E. 10 to the power of minus 4 is valid. Here also, see, these two are positive numbers. And this is a negative number. This is how you store a negative fractional number. This is how you store a decimal fractional number. Sorry, this is how you store a positive decimal value. Sorry, positive fractional value. Positive fractional value. This is how you store a negative fractional value. These two for positive fractional value. This one for negative fractional value. Yeah? Okay, I'll clear them. Sure now? Range is clear now? Now 3.4E 338 to 3.4E plus 38 minus 1.7E minus 308 to minus 1.7E. Imagine 308 numbers, man. 10 to the power of 308. It's very difficult for you to count. You know how now? Say count this value. We get tags here. Units, tens, 100, 1000, 10,000. Okay, very fast here. After that what? 10,000, lakh, 10 lakh, stop, crore, 10 crore, 100 crores, 1000 crores. This is only hardly 10 to 20 digits, hardly 15 digits. You are having here 38 or 308. Imagine what a big value it will be. Understood? Just sample I told you. Okay, in numeric data types, see extensively what we use are only these. So don't worry about others. Why I'll be telling you later. Extensively use, just mark it. We use only byte. Byte will be we don't use byte and short. We extensively use int and long. These two will be used extensively. And here only double will be used. For storing numerical values, extensively we use what? Int and long. Or for storing decimal value fractional value we use double. Extensively use that. So don't bother too much about byte and short. I am only telling you. We don't use it. Why I'll tell you. After this example I'll be telling you. So among this, you think about that now. So next, non-numerical values now. I'll clear this also. This range. Next, non-numeric. Can you guess how many non-numerics are there? How many types of non-numeric values are there? There are two types of non-numerical values. I think I'll. Same story here also. Data type, size, no range, default value. Boolean, mark करें बालाजी, marker. See, in most of the languages, to check whether true means you'll be using this in expressions. Still now I have not shown you expressions. Means arithmetic expression, Boolean expression. Okay, so there are some expressions. That is next. Will be for writing expressions we need what? Operators. I'll be teaching you later. But in most of the languages, whenever you want to write a positive, negative, if you want to check, what you do in most of the languages. In C also the same headache is there. Class demo. See, in C what we do is, say int I is equal to 0 if I you write. You remember that? Int I you'll write. Yes or no? Means if true, if false, that's how you write. But Java is not against this, because 1 and 0 are integer values and you are using it for a different purpose here. That they thought it is incorrect. That's why they gave some value like true and false. So I showed you 50 keywords. That time I told you there are two values there, true and false. They are not keywords. They are actually what? Values. So they are actually Boolean values. You can use those values in Java. If you want to check like this and all that, you can use Boolean value. So for storing the type of a value, true and false, they designed one more data type called as Boolean. That's it. So if at all I want to store a value in Java now, true or false, what we do is same. First I'll write I want to store this is a value in Java now. You cannot use this as a keyword. This is a value, but not a keyword. This is a value, but not a keyword. So this value, if I want to store, can I store it in byte? Can I store it in short? No, I cannot store it in any numeric data type. I can store it in only Boolean data type. So this is the first problem what developer faces in any language programming. In C also when you are programming now, this was the difficulty you are facing. Some value you are trying to store somewhere and you are trying to get the output, which was becoming very difficult for you. But here it's very clear. So if you want to store a false value, I use what now? Boolean B data type. Type of value, check now. What is the type of value? Boolean type of value. Can I store it in numeric? No. So type of value is very, very important to store. First is type of value. So here for this range size and all doesn't come. Range size and all will come only for what? Numeric. So first basic thing what is going to be applied is, when you want to store a value into a variable, the type of value is very, very important. Understood? So it will store now. And if you want to print SOPB, can you guess what it prints? False it prints. It prints you no 0 and all. It prints you clearly false. Now check. B is equal to true. I am changing the value. You can overwrite now. New value is there now. So what I will print? SOPB. What it prints? True it prints. Okay, now see, very interesting. This it will print no problem. Now I want to see. This is one relational operator. Greater than is a, arithmetic operators are there. Okay. So operators are not covered, but just I am showing you how Boolean can be used. In Java, in C what happens? You cannot store the result. In C you can store the result of arithmetic which an expression. See, this is arithmetic expression. Int A is equal to 5. Int B is equal to 3. Int C is equal to A plus B. I will be talking about expressions later, because I can teach you expression only after completing operators. But if you use arithmetic operator, what happens? It's called as arithmetic expression. And the result of an arithmetic expression can be stored in what? In a numeric data type. You can store it. But in C, you don't have this benefit. I cannot store the result of a relational operator. Sometimes you have to store this. So language is weak. It is a good programming language, C is successful, but it does not have the ability to store what? The result of relational operator. So you can see, like Java is nothing but a refined language, very refined language. So Java people observed this. Now it cannot be stored. That's when they tell you to use what? Boolean. Boolean C, valid. The result, A greater than B is what? True. It is stored in what? C. You can see it here. See, here I am hard coding directly, 10 greater than 9. So if I store that in B, SOP B, what will be the result? True. Definitely it will be true. No issues about that. Clear? So the result of an Boolean expression, the result of a relational expression, the result of a relational expression also can be stored into Boolean data type. That powerful it is. Not only that, see here, more things. Now what is the, okay, now shall I clear this now? This is over. So first you can print B is equal to false, SOP B you print true. Again you say B is equal to false, means reinitialize it to false. Then you say SOP B, what will be the result? False again. Then you say 10 greater than 9. Then you store it in B, SOP B, what will print? True. So first time it will print false, second time it will print true, then it prints false, then it prints true. See how it changes. Depends what value you are giving, it will store that. Clear? Anyway, expressions I'll be teaching you in depth later. Expressions are still not covered. Shall I clear all this? Okay, then more things. These are very tricky interview questions you get now. Very tricky. Very clever they are. See, they'll be asking you a lot of questions on this. Boolean B is equal to false, they'll say. See, in Java we check like this, if B directly. In C, how do you do the checking? If int I is equal to 0. In C you check like this. If I equals 0. But here nothing like that. This will get evaluated to what? In C, true or false. Understood? But here, if B is evaluated to what? True or false. But anyway, remember, you will be using Boolean values like this. But end of the day, you are writing if block also and you will be writing else block also. You always have a confusion. Which block will execute? When? Very simple formula. Okay, which block is evaluated to true? That is going to execute. That's it. Now if this is false, this is true now. Simple as that. So SOP, which block executes now? If block. If B means, if it is false means what? If this is false, obviously this has to be true. But see, the same I'll negate, not I'll use. I'll be teaching you all these operators. They're called as Boolean operators. So I'll be teaching you that. Okay, don't worry. If not B means what? If not false means obviously this is true now. So what will print? This not operator is very interesting. So if block will print now. Clear? So you should know how to work with this. Same thing here. See here I'll do ulta. Boolean B is equal to true. If B, SOP, if block. Else, SOP, else block. Now which one will print? If block now. If I say if not B, what will print? Else block will print. That's it. If not true means it is obviously false. Don't have any confusion there. Whichever is evaluated to true, that will get executed. That's it. Don't even see the negative side of it. Either if will be true or else will be true. Obvious it is. Both of them cannot be true, both of them cannot be false. No. They're opposite. If true, whichever is true, that gets executed. And you can do it in two ways. If B, if true also you can do, or if not true also you can do. See, in interview you get questions like this also. Sometimes they'll say if not B, or they'll confuse you like this also. If true also they'll say. If else. So if block executes. If not true also they'll say. They'll be directly using the Boolean value, man. Instead of storing it in a variable, they'll be directly using it like this. As simple as this. So almost all you're getting the grip of programming now. Getting it now? How value, what value, how to use it. So that's why data types is the pillar of all languages. In any language, data types is the pillar. How strong this pillar is, that successful the language is. Understood? Your pillar should be very, very strong. Then you can construct any number of buildings or floors now. That's why Java's data types are very powerful. At the same time, they are user friendly. We are nearly completed how many data types now? 7 data types. One more I'll complete off now, 8. Imagine 8 data types we are learning in a single day. How user friendly it is. Understood? 8 data types, you can't learn in, can you learn 8 data types in any language? Go and learn in COBOL, go and learn in Pascal. Impossible. But Java is easy to learn. Reason is it's following C syntax. Because we are comfortable with C, we are just seeing minor changes here. But we are not using one feature of C++ also here. Yes or no? So if you know C, you can start learning Java very easily. Shall I clear this now? Clear? Any questions? So Boolean over. Last now, character values. See, one more type of value comes now. Last value called as character values. First of all, what are characters? Anything in single quotes is called as characters. Anything in single quotes is called as characters. So to store that value, here again we'll see data type, size, default value. So there's only one data type to store your character value. Size is 2 bytes. Default value is space. Space. If you don't give any value, space will be taken. So there are only two non-numeric values. So let's see this now. First I'll show you with an output char x is equal to a. Then we'll discuss what they have done. SOP x, what it prints? A it prints. So I want to store what? A character value. To store character value, what data type did I choose? Did I use byte, short, int, long and all? No. I chose which one? Char data type. So type of value is very important. For that I store it in char. Clear? And one more thing, and internally how it is stored is, for us it is A, but internally A is stored as what? 65. What is 65 now? ASCII value. 65 will be converted into binary and then stored. Internally it is stored like that. A will be converted to ASCII value. Now what is ASCII value? There is one big full form, leave that. American Standard Code for something big, leave that. Don't bother about that. What was happening, the major problem in so many languages are getting invented. So many languages are getting invented across the world. Now every language had characters. Every language gave you characters for what? Coding. You know, character set in Java is having what? A, digits, all that. They have to give you. But most of the languages are giving the same characters. A means alphabets, digits and all that only. But was in one language they are giving one representation. One representation. Like in one language they are saying the binary value of A is 65. In another language they are saying the binary value of A is, that ASCII, some value, not binary value, some value. Every language is having its own type of value. And that value was converted to binary. Now developer was finding big headache now. First of all he has to learn a new language. On top of that, what is the value also he had to learn. That's why all the language people sat together. They came with one common conclusion. Okay, let us develop any language. But in all the languages, these characters will have the same value. And that value they started calling it as ASCII value. So C also uses what? ASCII values only to store A. Java uses not ASCII, it uses Unicode. So there are two standards to store values. Two standards. One is called as ASCII standard and the other one is called as Unicode standard. In ASCII, you can represent only 256 characters. In ASCII, you can store only 256 characters. In ASCII standard, only 256 characters can be stored. But in Unicode standard, 256 are represented, you can say. Can be stored, instead of that you can say are represented. And in ASCII, most of the characters are what? English and digits only, 0 to 9. Here, what are the different characters we use? A to Z, capital A to Z, small a to Z, and digits in ASCII. A Unicode standard, what are the different characters it represents? How many characters, first of all? 65,536 characters. It represents so many characters. Means ASCII standard is supporting only English symbols. ASCII standard is supporting only English symbols. Unicode standard is supporting what? Many language symbols. Japanese, Chinese, and all that. Okay. So first of all, now they said they invented languages, but in that language, which language you use to, which symbol you will use to code was up to you. Okay. And most of the languages were you giving you English language support only to code, like int I, char C. You are using what all there? English symbols. And C, C++, and that is actually ASCII standard. Okay. C, C++, and all follow this, but Java follows Unicode. Why Java is following Unicode means, or what is the difference? First we'll see Unicode and ASCII. ASCII is a subset of Unicode. You don't have to worry too much now. ASCII is a subset of Unicode. Means in Unicode you are having 65,536 characters. But what characters are there from 0 to 255? Here 0 to 255. In 0 to 255 some of the characters are what? 65 means capital A, 96 means small a. These are same in ASCII also. So they didn't change everything here. So they wanted to invent one more type of representation. So what they did, they sat together, all languages people, they had a common discussion and they came with a common conclusion. All of us will go with one standard way of representing the symbols and characters. They discussed and finally what they did, they came with first ASCII, then they came with Unicode also. In Unicode what they did, they took all the things of ASCII plus they added extra. So in ASCII only you can use what? English symbols. But in Java you can use other symbols also to code. But we don't use it. Don't bother. I will not be teaching you that. We use always what? ASCII symbols only here, or ASCII standard code only for coding here. But why did Java take this support? Java wanted to support internationalization. Means it wanted to support internationalization means they wanted to support means Java wanted to give multi-language support. It's a big topic, internationalization. I'll be discussing this when we are developing applications. When we develop applications, I'll show you how to do internationalization. Understood? Means in one country you want to display the content in one language and all that. No, so we'll see that how it will be done. So just understand only this much. Java is using Unicode. Java uses Unicode standard to support what? To support internationalization. That's it. But we'll not be using all that support. We use only the first 56 characters only, nothing else. We use only the first 56 characters. So same as you know, char x is equal to a. So when you say a, what happens? X a will be converted to represented as what? 65. 65 you convert it into binary. 65 you convert it into binary, it will be stored. But in Java, to represent these many characters, Java is taking what? 2 bytes. That's all. Java is taking 2 bytes, nothing else. So then SOPX, what it will happen now? It will print. Okay, you can do this also, x plus plus. Now 65 plus 1 becomes what? 66. SOPX, what it will print? B it will print. That's it. Clear? So I've shown you so many data types. See, the maximum used data types are only 4. Don't worry about char also, because we are going to store what? String values. We never use char. Just I gave you info. This one type of value, and for storing that, Java is giving that support type. So Java gives the support, but we developers will choose only few data types here. Understood? The language has to give the support. Otherwise, what will you say? It is not a good language. Understood? So language will give the support, but finally we decide what to use, what not to use now. Are you clear with this? Clear? Okay. Now we'll come to the concept of typecasting. So these are the values which are there. Fine. See, first write down. Casting. Casting is a process of Casting is a process of converting one type of value, one type of data value to another type. Understood? There are two types of typecasting. There are two types of typecasting. First one, implicit casting or widening conversion. Second one, explicit casting or narrowing conversion. This is very important subject. Take the first one, implicit casting or widening conversion. Implicit casting or widening conversion. First point. It is a process of converting. It's a process of converting a smaller data type to bigger data type. It's a process of converting smaller data type to bigger data type. Process of converting smaller data type to bigger data type. See, generally you tell in interviews this only. Precisely, it is not the data type which gets converted. What gets actually converted? Value which is getting converted. You are getting clear now? Right, one more point. It's a process of, implicit casting is a process of converting smaller type of value to bigger type. Understood now? Implicit casting is a process of converting smaller type of value to bigger type. Again, one more point also, it's a process of converting smaller data type to bigger data type. In interview tell that only. But actually, for your clarity I am telling, data type, see, can int be converted to float? Data type will not converted. The value stored in int will be converted to float. Remember, that's the meaning actually. Understood? So that's what I am trying to say. So it's a process of converting smaller data type to bigger data type. Other one what I told was, it's a process of converting smaller data value to bigger data value. Done? Fine. It happens implicitly. It happens implicitly. It happens implicitly and is taken care by the runtime environment. And is taken care by the runtime environment. That is JVM. That is JVM. It is taken care by runtime environment. JVM will do it for you. You don't have to worry about this. JVM will do what? This conversion, implicit conversion. Let's see this now. Right, one more point. This will happen. You understood what is implicit? This is also known as, next point you write, this is also known as widening conversion. This is also known as widening conversion. Also known as widening conversion. Next point you write. In implicit conversion, there is no loss of data. In implicit conversion, there is no loss of data. You know, in your typecasting, loss of data is happening now. In implicit casting, it will not happen. We'll see that now with the example. In implicit casting, there will be no loss of data. Very simple now. See, you will only understand all the code now. Because you understood all the data types, in 1 minute you will understand all the typecasting things now. See, I am having what now? Byte A is equal to 5. Int I is equal to 0. Okay, SOP A, SOP I. What it will print? 5 and I. 0. This is the output. 5 and 0 it will print. But now I want to give the value of 5 to I. I want to give the actual value of 5 to I. But actually 5 has been stored where? In A. So how will I give now? I is equal to A. So this itself is called as what? Implicit casting. So now what are you trying to do? You are trying to give 8 bit of data to 32 bit. Exactly, see here what has happened. Byte A is equal to 5. So there is 8 bits now. So this is how 5 has been stored in byte. Now that has to be given to I. So I have declared I. I is having what value now? Totally I is having what? This is I. See, I will have 32 bits. I can't write all the 32 bits here. Just I am writing this is, assume that this is 24 bits and this is 8 bits. I can't write that. So you sit and count if you want. Okay. So what I'll do now, 8 bits, 24 bits, all will be what? 0. Don't bother about this one now. All will be 0, 0, 0, 0, 0, 0. But last 8 bits. See, you are trying to, see, initially all are 0 only here also. Because you told int I is what? 0. Now what are you trying to give? The value of a you are trying to give I. So it will copy. So only the 8 bits will copy. So from here it will copy here, from here it will copy here, from here it will copy here. It is copying 0, 0, 0, 0, it will copy. So this is what? You are converting one type of value to other type of value. Means it's converted from 8 bit to 32 bit, and after converting to 32 bit it was stored in int. No issues at all. Type of value is correct, range is correct, size is correct, happily it will store. No problem only. So this line only is called as implicit casting, and developer does not have to worry about this. Compiler will take care. Oh, this value, no, it can store, no problem. Understood? And implicit casting, it is taken care by what? JRE or JVM. Sometimes we say JRE, sometimes we say JVM. JRE means Java Runtime Environment. JVM means Java Virtual Machine. There is some difference, but right now think that both are same. Done? Are you comfortable with this? It happens implicitly. And there is no loss of data. In I, what will you find? 5 only, no? In I, what will you be finding? 5 only. There is no loss of data. But in explicit casting, there is possible chance of loss of data. Let's see that now. So let's go to explicit casting now. Example for what now? Okay, 1 second. Okay, you can convert now. See, if I want, I can give more examples. Implicit casting. Some more I'll give you. Wait. I want to store 5.5 in, 5 in float. I think, we check this out. If I add f, it will store. Okay. Or if I get float, we'll take double, it will be more meaningful. I'll say double d is equal to a. Valid. You can store that 5 in int, or you can store it in double, or you can store it in short s is equal to a. All are valid. It's up to you where you want to store. Understood? Okay. Shall I clear this now? Take the next example. Explicit casting. Next heading. Explicit casting. It's a process of converting bigger data type to smaller data type. It's a process of converting bigger data type to smaller data type. Process of converting bigger data type to smaller data type. Next point. It's a process of converting bigger data value to smaller type. Yes or no? It's a process of converting bigger data value to smaller type. We'll convert big value to small now. It's a process of converting bigger data value to smaller type. Both are correct. You can say any statement, but actually one is not that very technical. The second one is more technical. That's it. So now scenario is ulta. Earlier what was the scenario? Byte a is equal to 5, int I is equal to 0. Scenario was I is equal to a. No issue here. This is implicit casting. It will happen. But now scenario, I think this is another program. Byte a is equal to 0, int I is equal to 5. Now the value stored in I want to give it to a. So to give it, you will write like this. Valid. But here the problem is size of it. Type of value correct. Range of value correct. Only the problem is size. So what will you do now? Means you have to do type casting. This will not happen. Compiler warns you. You are trying to give some value to something. Check. Later on you might get problems during runtime. It's clearly warning you. Understood? So that's why this cannot happen now. Compiler will give you error. So for doing that, we typecast. Byte of. And you know the syntax now for typecasting? What is the syntax? What is the syntax? This is destination, then target type, then source. This is the syntax. Use this syntax, which is the destination byte. A is the destination. Target type is what? Byte. And what is the variable? I. So I will be converted and will be stored. Means see, here ulta will happen. First I will be having 101. Byte I will be having 000. So from here it has to be copied here. Now can 32 be put into 8-bit? Not possible. How can you put such a big value into small value? Not possible. So what will happen now? You have to reduce the size. So for that I am doing typecasting. So what happens now? That 32-bit will be reduced to 8-bit and then it will be stored. So now when it is converted to 8-bit, it checks whether it is within the range. It is well within the range. If it is within the range, there is no loss of data. The loss of data will happen only when it is outside the range. So that's what I told you. When you do explicit casting, there is possible chance of loss of data. You will not have loss of data in implicit casting, but definitely there will be loss of data in explicit casting, provided it's outside the range. Don't think in our explicit casting always will have loss of data, only when it is outside the range. And you know what is range now? Now see, I'll make it as, instead of I, I'll make it as 5, I'll make it as 130. So it is now converted from 32-bit to 8-bit, but it's outside range. See, all the three things should be satisfied. Type of value, size of value, range of value. Type of value is correct, size and range are the problems. So what it will do now? Size also it will reduce, range also it will reduce, and now loss of data will happen. Clear? So this is typecasting. More examples I'll give. Shall I clear this now? Okay, see this, one more. I will clear this. Okay, see one more example. Now byte A is there, is equal to 0. Double D is equal to 139.598. Now very interesting typecasting. You are trying to convert fractional to what? Whole number value. Fractional to whole number value. Okay, so what will happen now? A is equal to byte of D. Now type of value is problem, size also problem, range also problem. All three problems now. Here what was happening? Only two problems were there. What were the two problems here? Size and range. Type of value was correct. Here type of value was correct. Range and size were problem. Here what's happening? All the three are problem. But it can still be done. Type of value, first it will convert what? Into whole number. How it will convert? By truncating. First truncation will happen. Understood? After truncation what will happen? Then it will bring it within the range. It will bring it within the range. Then it will reduce the size. Then it will put it. So definitely there is loss of data. So like this, you see if I convert double to byte, you will be getting some value. But if I convert it to int, what will happen? If I convert to int, definitely I will not be losing value. I will be losing only a decimal value. So in byte, if I try to store it in byte, I will lose, let us make it as instead of 120, I will make it as 129. 129.598. So what will be the story in, what will be the value in A? Minus 128. Sorry, 127. Minus 127. But the same if I store it in int, what will be the value? 129 itself. Only the decimal value will be removed, and it is within the range now. It is within the range. Easily it will be stored. So like this you can go on storing. Understood? So it depends now what is the type of variable you are using to store the data. Understood? What type of data type you are using to store the, what type of data type you are using to store the value. Okay. So in the first example here only two problems are there. What are the two problems? Size and range. So these two things will be converted. But here all the three problems you are having. Type of value, size of value, as well as range of value. Type, size and range. All the three problems you are facing here. Okay, for which one? When you are doing it for byte. But for your int, range no problem. So check out, it's very simple now. Okay. So clear. So now see, typecasting can be done only between numeric types. That you understand now. That's very important thing now. You can typecast from what? Whole number values to fractional values, or fractional value to whole number values. You cannot convert a numeric value into non-numeric, or non-numeric to numeric. This is not possible. So don't try to typecast anything to anything. Don't try to typecast true to what? Int. Boolean b is equal to true. Don't typecast that to int. Similarly, character value is there. Don't try to typecast it to double. So typecasting is possible only here. Understood? You can't typecast these two. They are separate. Are you clear with this? So simple typecasting. Correct now? In C you struggle so much for typecasting. It's so simple in Java. It's very clear. So for understanding that only, you should be very strong in data types. Should I clear all this? Say just I'll write an example and you will only understand. See, there is a value called as Boolean b is equal to true. Now this I want to store it in int I. Impossible. How will true get converted to int 1? Or how will int get converted to Boolean? Not possible. This is error. So that's what. Typecasting is only possible where? In only numeric types. Here to here, here to here. Anything. See, smaller to bigger, implicit. Bigger to smaller, explicit. And from whole number to fractional, fractional to whole number. This is all is correct. But not from there to here. Clear? From here to there also you can't do it. As simple as this. And last thing, in Java you don't have unsigned integers here. Java has removed the concept of what? Unsigned integers. It is not there in Java. In C you have unsigned int, no? See, here in Java everything is signed only. That's one last thing, no? So I'll write int I is equal to 10. Okay, but in C you can do this. Unsigned int I is equal to 10. Means what happens when it is actually stored in the memory, no? This 10 or whatever you store. Okay, I'll take it 5, it is easy. The last bit indicates the sign. You can control this last bit in C by telling what? Unsigned means it will be 0 only. By default it is signed, it will be taking in C it is, you can make it as signed or unsigned. Just understand, don't go more deeper into this. In C it can be made as signed or unsigned, but in Java you cannot make it as unsigned. That's it. You cannot make it as unsigned. All are signed in Java. That's one last thing about Java. Okay, so this unsigned keyword has been removed in Java. Because they are not supporting it, they have removed that keyword. Clear? Okay, this completes all this. So tomorrow I'll go with what? Arrays. Tomorrow I'll be going with arrays. Do you have any questions here? Perfect, data types, primitives?
So if type conversion between int and float, size is same.
No, only truncation lab. The typecast. Try it out. Compiler is going to teach you better, no? Who is teaches better? Me or his question is what you want to convert to what?
Between int and float.
You want to convert int and float. No, from int to float or float to int?
Float to int.
You want to convert from float to int. So float f is equal to 1.9 f. You have to add suffix f. Now obviously I have to store it in int I. How will I store now? You tell. I taught you all rules of typecasting. You tell now. I is equal to, how will you do now? You do.
I is equal to float int.
I is equal to float, int of f. That's it.
Implicit or explicit?
You tell. Implicit or explicit, you tell. This is implicit or explicit. He is telling the code. He is himself telling the code. And he is asking me ulta whether it is implicit or explicit. Now what should I tell? Now you tell whether it's implicit or explicit. You are telling me the code how an int is getting converted to, or float is getting converted to int. You are telling me the code. And now on top of that, if you question me it is implicit or explicit, what is the answer I should give you now?
You told if conversion from bigger to smaller.
This is big because it's having fraction.
So, but size is same. 4 bytes, 4 bytes.
4 bytes, 4 bytes, sir. But type of value is problem, no? Size is same. All the three things should match. If you want to give a value to a variable, all three things should match. Especially numerics. Other two will not come in which one? Character. In character will not have range and size. But when it comes to numeric values, all the three things are taken into consideration. So here size is correct. Range is correct. What is the first problem basically? What is the first basic problem? Type of value, no? And then what you have to do? Yes or no? Observe all the three rules. That's why I wrote at the beginning of the class only. These three rules, because you make mistakes like this. So this is explicit casting. Next, ulta will do. What? Storing int I is equal to 1. I want to put it to what? Float. Float f is equal to I. What will happen? It will be, if it doesn't work, it might be taking it as what? Double precision. If it doesn't work, put f. So make it as single precision. Understood? If it doesn't take, if it, because see the type of value is the problem. What is the type of value? If it is single precision, it will store. But if it is taking it as one is taken as double precision, obviously you have to convert double precision to single precision. But definitely int I can be stored in what? Double D is equal to I valid. Here no problem. Clear? Check this out. Compiler teaches you better, man. You type, compiler will tell you. It will not tell me like this. It means how I teach, you know. It will not teach. Very, very politely it will teach. Hello sir, this is your problem. Check. Very clearly it will tell. Okay. So you try with the compiler will give you. This is the basics I have set. And you will get plenty of questions now. Because it's a huge language, huge things are there, you will get plenty of problems. You try to code. Whatever problems are not resolved, you bring it to class. Definitely I will be resolving your problem. But without trying, how will I teach you? So all this you have to go and practice today.
Convert ASCII to integer and
ASCII to integer, integer to, it is possible. Means you can write the thing like this. Int I is equal to A, it is possible. SOP I will print 65. But we don't do all this, simply don't practice it also. Can we convert ASCII to integer, integer to ASCII? Char C is equal to 65, valid. One more now, char X is equal to 65, both are valid. But we will not do this. Simple programming we will do. But think of applications now. In application, why will we be doing all this? That's the reason first I draw the diagram. I told you UI will be this. Such kind of values will enter your application. So these kind of things we will never do. So obviously what you will be using is only 4 data types here. Int, long, double, boolean. That's it. We will not use any other data types. Understood? Language gives the support, but we will not use it. Clear? Any other questions?
At first, byte to byte when we convert it. Anyhow, we are going to lose that value. Then what's the use?
You have to decide. You are the developer. You want to store a integer value in byte. You are telling it. Compiler is very clearly, I will not allow. But you are enforcing, no, I want it to be stored. Language has to support now. Language will give the support. But loss of data also will happen, it is telling. No, you have to decide whether you want to convert int to byte and store or not. If you don't want, use another int. I am not telling there is no, what is the use, right now we can't discuss. Usages we can discuss when we start seeing in applications. Okay, but these are the different problems we get while programming. I am telling these are the different problems we get while programming. So if you are having this kind of a programming problem, language supports you in this way. Take it in that way now. Instead of saying what is the use and all that, language is giving the support for us to program in this particular ways. Yeah? Okay, any other questions? So tomorrow we'll be seeing arrays. Very powerful. Okay. So once you know this, see, once your primitive types are clear, our arrays will be of type what now? These types. You can have an array of type int, an array of type float, you can have array of type double. So be careful with the which one? Basics, so that tomorrow when I start writing arrays, it will be very user for you, means very comfortable for you. Very comfortable for you. So when I start creating, means using an array, you will understand what it is now. Arrays are what? Simple now, group of similar data. I can have an array of int, I can array of boolean, I can have an array of character, anything I can have. So that's it. Clear? So this table is going to continue, and I'll finish off this table today. Tomorrow I'll only teach you the which one arrays, but tomorrow I'll not draw the which one this table. So let's finish it off today, sir. Last thing. So user defined data types. Java is giving you now how many user defined data types? Can you guess? Somebody told 32 user defined data types in C. To learn 8 primitive type only, you are struggling here. At the beginning somebody questioned, what they questioned? C is better than Java because C is having what? 32 user defined data types. Where C is having 32 user defined data types, man? 8 data primitive only we are struggling to learn here. So C is having only 3 user defined types. Java is having what? 6 user defined types. Simple. Okay. But in C it is difficult to learn and use the user defined data types. In C there are no 32 data types. You are wrong. I am just clarifying that doubt to you. Okay. Somebody had told that at the beginning. Okay, fine. See here. You are having 3. So one, you have got something called as annotation. This is one data type. Other data type is enum. There are other 3 data types now. I have to classify here also. See, annotation is on data type in Java. Understood? It's on data type. Don't bother what it is. And it is used for metadata programming. Just understand this much. Metadata programming. Enumerations are used for defining constants. If you want constants now, we use this. Now there are again 3 more user defined data types. See this. Here. You are having something called as class, you are having something called as subclass, and you are having something called as abstract class, and you are having something called as interface. So there are 4 user defined data types in Java. 4. Okay, we have completed 8 primitive types, leave that. Now in user defined types how many are there? Totally 6. But I am classifying it like this. Later on you will understand this classification, don't bother. Just we'll complete of this table. Again I cannot write the table. So one is annotation. Okay, second one is enum. E-N-U-M. E-N-U-M. Annotation, what is the spelling? A-N-N-O-T-A-T-I-O-N. Annotation, enum. Now here, like you have got structure, enum, union in C, no? In Java you have got class, subclass, abstract class, interface. Now once you define your data type, user defined type, you will have a variable of that type, no? You say, no, in C what you say? Struct student, you will define it, and you will define everything here. Then you start using it, no? Struct, and you will start using it. So you will have a variable. There the variable is called as what? Pointer. But here we call it as reference variable. We'll see it later, don't worry. Size. The size of reference variable is for all 8 bytes. Just write 8 bytes. Default value of all this is null. And this null I'll be teaching you later. What is this null value? I'll be teaching you later. Today we saw literal values, 2 literal values. What is that? True and false. So one more value is there called as null. We'll be seeing it later. So this entire table completes what now? Data types. See, very clear it is. Very, very clear. Very, very clear. So neatly they are done. If this cleanliness is not there, you cannot write any logic here. Yeah? Okay, we'll complete the class. Thanks.